With the notes from yesterday, do some examples. Now, what we're going to do here, guys, is focus on there's two schools of thought in regard and two practices that we need to go through, and it's understanding how numbers relate to one another. We're going to go through and we're going to do things so that we have exact answers. Okay. The purpose of this is so that when we are asked to round to a particular decimal place, if I have the answer as an exact version, I should be able to grab my calculator, type in the exact version, and then it be correct out to however many decimal places I need. Does that make sense?
Yes.
Where if I start rounding intermediate values and using those intermediate values through other calculations in the problem, I'm going to compound my rounding error. And maybe I only rounded a number by 2/100ths. But if I double that, and then later I multiply that by maybe 8 to get a perimeter, I've now ultimately amplified that rounding error by 16 times. Okay, and that can be a problem. Okay, now when we're going to work through these and kind of show that discrepancy every once in a while, and you might say, well, that's not a big deal, and maybe it's not. I mean, we find, I think, an error here of like 0.14 here in a little bit. 1/10 of an integer. Is that a big deal? I don't know. Depends on the situation. Yes, it depends on, what do we need this area for this octagon for? Okay. Maybe in some aspects the 0.14 not a big deal at all. Other aspects, maybe it's a very, very, very important thing. Okay. It's just a lot of times dependent on the criteria of the problem. Okay. So I want to do things with exact values. And another reason for this is some of you are going to take college algebra, trigonometry, calculus, okay? And at that time, we can't spend time teaching you how to write between exact answers and non-exact answers and do the algebra with the work. It's part of that class where we just start displaying numbers as exact values, and we don't ever talk about how do we do that. Okay, because those are prerequisite things. Okay, that we should have been learning in Algebra 1 and Geometry. Okay, so yesterday we had the formula area is equal to 1/2 AP. 1/2 AP. A is the apothem.
P is perimeter.
And P is the perimeter. Okay, so the apothem, remember, is that distance from the center perpendicular to a side. Okay. There's a couple things that thing did. Remember, it bisected this side, and it also bisected this angle up here. And that's why I'm only drawing half of that angle, because this triangle is really the triangle that I'm interested in. It's going to provide me all the missing components of my formula. Right here, this question says we start with the perimeter of 72. So right there, they're explicit, and you have the ability right away to just plug in capital P. Because I know that there's going to be a fraction here. This is already a fraction. This is probably going to be a fraction, so might as well make this a fraction.
Well, because my homework, I was using good calculator, so I just typed.
Okay, well, on the test next week, you get a question like this, and it's on the portion that you can't use the calculator. What are you going to do? Hopefully,
Fail.
Throughout the class, we've learning how we multiply fractions and that kind of stuff. Okay. All right. So, it says the perimeter is 72. So, if the perimeter is 72, what is maybe that side length right there?
72 divided by 9.
72 divided by
8.
8 gives me 9, right?
9.
So, if that's 9, that means all these sides are 9, right?
Yeah.
So, this side down here is 9. So, what would
3.5.
What would that be? Okay, it's 4.5. Now, I'm not going to write things as decimals. I'm going to avoid decimals, even if they terminate. I'm going to write this as 9/2. Okay. Now, in the event of trying to find my apothem's length, I need to use SOHCAHTOA. So to use SOHCAHTOA, and this is consistent in all these shapes, whether it's an octagon, a decagon, dodecagon, whatever. I need to find that angle right there. Okay? You guys remember the formula I gave you yesterday to find that angle?
Yeah.
That we worked through? How do I find it?
I used to all stuff at the hub.
Nobody remembers how to find that angle.
Is it 360 over 2n?
360 over 2n, where n is our number of sides. Okay? So in this case, we get 360 divided by 16. It gives that angle to be 22.5 degrees. Okay?
16.
Now with 22.5 degrees, I'm going to leave it as a decimal there. Okay? With my degrees, with the if it's going to be inside a sine, cosine, or tangent, I'm going to, if it terminates, leave it as a terminating decimal. I'm not going to write it as I could write it as 45 over 2. But in this case, I'm going to write it as that 22.5. So it's not a big deal. All right. So now finding A, would you guys agree that this side here, this red side here, is opposite? And the apothem, which is the blue side, is that adjacent to this angle of 22.5? Yes. Okay. So, which trig ratio uses opposite and adjacent? Tangent, right? Okay, so we're going to go tangent of that angle, so 22.5. Bear with me, my mouse keeps lagging. So 22.5 is equal to opposite, so 9 over 2, divided by adjacent, which is A. Okay. What have we talked about with examples like this when the variable's in the denominator? What happens to these two things? The tangent 22.5 and A. They do what? They switch spots. So we get 9 over 2 divided by tangent of 22.5. Okay? Now, I'm not going to take that and write it as a decimal, because if I write that as a decimal, which is the easy thing to do, I'm going to have to round it. And then it messes up my area. It doesn't give me the most exact area possible. So, I'm going to talk about how I take a fraction, 9 halves, and divide it by a fraction, tangent 22.5 over 1, and write my apothem that way. How do I take a fraction divided by a fraction? Multiply by the reciprocal of that bottom one, right? So it's going to be 9 over 2 times 1 divided by tangent of 22.5. So that math gives me 9 over 2 tangent 22.5. Okay? Now, as we're doing these, you will thank me 2 years from now, 3 years from now, when that math is just second nature. Do it every day, do it every problem. Okay? So my hopes are is that you start to, take that in now. Okay? Start learning now. Start understanding that now. And it'll make your life later on a lot easier. So that's my apothem. That's A. And that's what goes in this formula up here. So put 9 up here. Tangent. Oh, forgot my 2. 2. Tangent. 22.5. Okay. Now, as we do that, okay, we have some multiplication that has to be done here, right? When you multiply fractions, you do it straight across the top. So 1 times 9 times 72. Okay, it gives me 648. Okay. On the bottom, would you guys agree that that 2, and that 1 all come from a similar group of numbers?
Yeah.
They're all rational numbers, meaning they can be written as fractions. Okay? Tangent of 22.5 is not a rational number. Okay? So we multiply these numbers together, 2, 2, and 1, and that gives us 4. And then there's still that blue number down there, and it's unlike the 4, so we just
let it go through.
yeah, we put multiply, we put the implied multiplication, we just leave it that way. This number ends in 8. This number is 4, so they're divisible by one another, right? Okay. 4 goes into 64 how many times?
You're going too fast.
16. 4 goes into 8 how many times? 2. So 648 divided by 4 is 162, and that tangent of 22.5 is left on the bottom. Okay, so those two cancel. Yeah, I just divide 648 by 4. All right, and that's just reducing. Okay, and now that is the best exact answer. Okay, usually with these types of questions in Math Excel, they're going to ask you to transform that to a decimal. But now, because inside that blue number, 162 divided by tangent 22.5, in the creation of that number, I never rounded a single value, right? So I should be able to, if I have a powerful enough calculator, write that out to whatever decimal I need it to be written out to, and I know for certain that that is accurate. Does that make sense? Okay. So, you know, Desmos or your 83s and 84s, those types of calculators, I think they go out to like 10 or 15 decimal places. Desmos goes out to 10. I can type in 162 divided by tangent of 22.5, and that is my exact answer. Now, only what I highlight up to that 0, I'm confident in. Okay, I'm not sure about the 4, because after that 4, maybe that 4 was actually a 3. And Desmos is seeing that after that 3 is a number bigger than 5, so it rounded it to a 4. Or maybe that number should be 4, and the number after it is less than 5, so it kept it as a 4 rounded down. So I never know what that last decimal is, but up to that one that I highlighted, that 0, I know that is accurate. Does that make sense? So they ask me to go to the 10th place, 100th place, 1000th place, 2000th place, 100,000th place, whatever. I can do that and be confident, 100% confident in those values. Okay. Where, if we did rounding, let's do some rounding here, okay? My apothem, we said was 9/2 divided by tangent of 22.5. So that's my apothem, okay? If I go 0.5, times my apothem of, let's say we round it to 10.86. Okay, so this is my apothem. This is what we did by hand. We found that to be apothem. This is 1/2. Your apothem times your perimeter was 72, right? So it gives me that number, 390.96. Okay?
That's close.
It is close, but if they ask me to round my final answer to the nearest tenths place, this one would be 391.1, right? This one,
391.
we would round it to 391.0. Not the same number, right? Does that make sense? And that's where people are going to make mistakes in Math Excel, because they rounded intermediate values and they're not getting the right 10th place, 100th place, or whatever. Okay, it's not a big difference if we subtract these. If we subtract these, okay, we get 0.142. That's not a huge difference. Okay, let me rephrase it. It's not a huge difference if I'm doing something like carpeting or flooring, like an octagonal gazebo or something like that, or an octagonal room.
If you're making a bomb, then
That's the stupidest thing ever.
if
If I'm doing something scientific, real scientific, okay? We use hexagons and octagons a lot in science, okay? You know, the structures of like a lot of carbon things are hexagonal, okay? The military has been making wheels, okay? That obviously in combat, having wheels that have tubes in them is a problem, right? Because when you shoot them, then we're stuck, okay? So they've created these wheels that are structured using hexagons, okay, as kind of the structure to create the wheel, and they can go through water real easy, okay. They can, they're kind of impenetrable with bullets and shrapnel and that kind of stuff. So in those aspects, it might be beneficial to use exact values as much as we can, okay.
why'd you call my idea stupid?
Huh?
Your idea is stupid. You don't know how to make bombs.
All right, so
You're that much off major.
this depending on the context of the problem, this rounding error could be problematic, okay? To where if we do this, if we find our answer that way, we'll never run into that problem. Even if I want my answer to a decimal, I can easily convert it to a decimal, right? Does that make sense? So that's why we want to go through that. Kind of a rule of thumb through all mathematics and all science, if you have to round, round as late in the problem as possible. Okay? I want to do this question.
That one was hard.
Okay? Area of a 15 gon with a radius of 6. Area of a 15 gon with a radius of 6. Does anybody want to draw a 15 gon?
I do.
No, that's a pain in the butt. Okay? Drawing a hexagon, octagon, those such things are problematic, and when you're done, they never look right. But if we look at every one of these pictures that we've done, every one of these examples, they all kind of have,
Like a stop sign shape.
yeah, they kind of all have that little bottom part, don't they?
Yeah.
Go back to that one. Does that bottom part kind of be right there? Okay. If I go to this one, is that bottom part like that? If I go to that one, is that bottom part there?
Yes.
Even if I go to this one here, that bottom part might be what's inside that circle there, right? So every one of these shapes, no matter how much I have of it, no matter how big it is, no matter how many sides I have, is going to, at some level of zooming, will have kind of that base, right? And in all of these, we've been taking that segment, which is our apothem,
Cut it in half. Or we cut the base in half.
right?
Or we draw a triangle.
Okay. So this distance right here, this hypotenuse, is the what of the hexagon, or not the 15 gon.
What you said?
This distance here is my
Radius.
radius, so that's 6. Okay. In my area formula, I need 1/2 apothem times perimeter, right? Okay. So I want, well, let's round this. Let's go to nearest. Let's go out to,
200.
let's go 6 decimal places. Okay. So if I want to go out to 6 decimal places, and the reason I'm going out so far is to inhibit you from wanting to round intermediate values. Because I'm going to round intermediate values, and my final answer needs to be 6 decimal places, and my intermediate values probably want to go out to like 9 decimal places. Okay. So nobody wants to do that. So this should keep us from being able to, or want to avoid doing that. Okay. In looking at this picture, do I have my perimeter? No, I don't know a side length yet, right? Do I know my apothem? No. Okay. This is usually the hardest version of these questions because you don't know either of these things. They hide them both in the fact that you got a 15 gon with a radius of 6.
Well, yeah, you know the base. Because we'll figure out what kind of triangle it is. You might know the base.
This angle, remember, we're always going to find that angle, don't we? Okay. So that angle is found by taking 360 divided by 2n. There's n, right? So I'm going to take 360 divided by 30. 2n is 30. We're going to take 360 divided by 2n. So 360 divided by 30 is 12. Okay, so that angle becomes 12 degrees. Okay, so that angle is 12 degrees. Okay. Now, if that's 12 degrees, would you guys agree that the R, or the radius, is the hypotenuse of that triangle? And that A is the adjacent side. So in SOHCAHTOA, which one of those uses adjacent and hypotenuse? Okay. So I'm going to write cosine. Cosine of that angle is equal to the adjacent side divided by the hypotenuse.
Did you just make up 30?
So the adjacent side divided by the hypotenuse. Okay. So now I'm going to multiply both sides by 6. And my apothem becomes 6 cosine of 12. Okay. That's my apothem. Can I do the same type of thing to find that distance right there.
Sure.
Okay. Now, why would I need to find that distance? Okay, because that's half of this bottom side, right? And if I can find that bottom side, isn't that one step away from finding the perimeter? Okay. So, if I look at the 12, can I say that sine, do it over here, sine of 12 is equal to opposite over hypotenuse? And then 6 sine of 12 would be that opposite distance. It'd be that red distance. Now, what do I do with that red distance to get that distance? Multiply it by 2. So I'm going to take 2 times 6 sine of 12. Okay? And that should equal a side of the 15 gon, right? Now, there's 3 numbers here. That number, and that number. Sine of 12 is a decimal, right? Okay? Which of those, which 2 of those 3 numbers work the best together? Or are most alike one another? Or come from the same group of values? Don't think about 12 as the number. It's sine of 12 as the number. 2 and 6 are rational numbers, right? And think about this. If I were to look at it this way. Let's see here. 2, 6, sine of 12. Which of those numbers are, of those 3, are most alike one another? 2 and 6, right? Sine of 12 is this ugly thing, okay? So what we do is we take the 2 and the 6 and we multiply them together. So it goes 12 sine of 12. That then is one side of my 15 gon. How do I use one side to find the perimeter? Yeah, perimeter is 15 times 12 sine of 12. And that should give me my perimeter. Now, that's a number, and that's a number. Of those 3, which 2 relate the best? Or work the best together? 12 and 15. So I multiply those together, and I get 180 and my sine of 12. And that is your perimeter. That's a capital P. Over here you had lowercase a, right? You had your apothem. We plug that stuff into our formula. So plugging that stuff in my formula, do it here in black. Area is 1/2. The apothem, 6 cosine 12, times the perimeter, 180 sine of 12. That's, there's some work that can be done with that yet. Would you guys, for the same reasons I already mentioned, that 1/2, 6, and 180 are numbers that work well together? Okay, they're all rational numbers. So if I multiply them together, half of 6 is 3. 3 times 180 is 540. Okay, and then I've got my cosine of 12 and my sine of 12. And that is the best way of writing the exact area. Okay? Now, I know there's a lot of work there, right? But we have done all of those intermediate steps by themselves at some stage in this course. Okay? We're just now putting them together. Okay? Now, like I said in the past, maybe I want to go out to 6 decimal places. Well, now I have that exact answer. I should be able to do that pretty easily. I should be able to write 540 cosine 12 sine 12. Okay, now it's giving me a negative value because I'm in radians and you go degrees. So 109.81, 109.81889363. I'm confident up into that 6 of what the exact answer at any decimal is. Okay? Does that make sense to everybody? Okay? Now, what we do in a trigonometry class, so people have asked, what is trig all about? In trig, we're interested in saying, okay, if I take 540 cosine 12, are there any relationships that allow us to maybe write that number a little bit easier? Would you agree that those 2 decimals are the same number? Okay. Which would you agree that the 270 sine of 24 is a little bit less congested, a little bit less messy than 540 cosine 12 sine 12? Okay, so that's what we do in trig, is we recognize, we develop why that works, okay? And how I came up with that 270 sine of 24. If we were to, like I said, do some rounding, let me go through this real quick with rounding. So 6 cosine 12, that was your apothem, okay? What we have, 6 sine of 12 it was that little red distance in my right triangle. It was that opposite side of my right triangle. Let's say I round that number. I'm just going to be haphazard about it. Round that number like that, okay? We want to double that number to get the full side of my 15 gone, and then I'll multiply it by 15 to get the perimeter. So there's my perimeter, 37.5. So right now I got 1/2. My apothem, which let's say that's 5.87, this number right here, rounded to 2 decimal places, times in 37.5. Okay? Would you agree that that number right there and that number right there are in the ballpark of one another? Yeah. Okay? And the only reason that they're different is because we rounded, right? Okay? Now we rounded, I believe we rounded every number up. So you see then that is why that is an overestimate of my actual area, right? Okay? Where if we're in Math Excel, we're on the end of course exam, and the end of course exam says write your answer so that you can be accurate to 1 decimal place, to the 10th place. Okay? If I do it in that last version, 110.06, I should round up to 110.1, right? But they've got it programmed in the back as 109.8. You are very close, but what's it say about you? You're wrong. Okay? So make sure that we understand that discrepancy about when to use exact values and when not to. Okay? If you're a person that on Monday struggles with exact values, and I know it's not the easiest thing to mess around with, okay? But it asks you to round to the 10th place or the 100th place, and you're going to round intermediate values, please round those intermediate values out to like 4 or 5 decimal places. Okay? Because then your final answer will be at least accurate to 1 or 2 decimal places. Okay? But the key thing for us as we move on is to kind of work with these versions of the numbers. Okay? And that's one of my goals for you as we in the year start to get better at that, because it will make Algebra 2 a little bit easier for you. It will make any class that you take after this easier for you if you can do that. So there are a couple questions in your homework that dealt with squares and triangles. Okay, squares are regular polygons. Okay, so if I draw a square, okay, I still have that thing in there, right? I still have that right triangle. It just makes this 45 degrees, that 45 degrees. So this is my n radical 2 side in a 45, 45, 90, right? I can still use 1/2 a times p. Okay? If I'm dealing with a triangle that is regular, it means it's an equilateral triangle. Is this triangle still in there? And that would be a 60-degree angle. Okay, so you got 30, 60, 90. Okay? I sent you guys homework in an email. Please check that. Also pay attention to other homeworks that are still due tomorrow and then the following day.